In this section, we're going to get into the wiring phase. Time to remount the components on the chassis, get some good grounding practice, some good wiring practice, and we need to get this thing taken apart fully so I can remove all the parts that need to be cleaned up. The lugs need to be cleaned out, with all the old solder, and a lot of parts need refurbishment. Some may need replacement. So this is the Steampunk Regen, and we're all the way up to part 5. So as you can see, I've disassembled the receiver. The receiver really needed to have some of the parts cleaned up. In a last-ditch effort to make the set work, somewhere along the line, somebody decided to put solder on every single terminal post. So all of these were caked with solder. And I had to find a way to get them off the posts and then spin them up to clean the solder off these. This is kind of the before on the side panel for the plug-in coils. As you can see, some of the components are like a diving board. And these have nice mounting holes. And I think that those mounting holes should be used to mount the parts properly to make the wiring more stable. So there's a little more cleanup to go on this one. But I finished the cleanup on this side. Everything is stripped out. The captured nuts, which is a very, very clever way of doing a blind assembly. A lot of those nuts were falling out, so I glued those in. I put a little coat of butcher block on the wood just to stabilize that a little bit. That wood was very, very dry, and it would collect moisture very easily, so I put a little coat on that. And all of the terminals have been cleaned of solder, so you can easily put wires through them. I'm still not happy with the dials making too much noise. This is going to have to be taken off, cleaned up, and a little bit of work done to make the tuning smoother. But the potentiometer for the Regen and the switch both appear to be in good working order. So this is the dial on the front of the Scotty Regen. Very decorative and very miniature. It's a beautiful vernier dial. You can see the mechanism is a pinch wheel working against this larger wheel. Now the plating is very good on this, except where it makes contact, and this is due to the pinch wheel probably taking some of the plating off, and that is where it's corroded, and that's what's causing the crunchiness. So this is going to have to be cleaned up, and we're going to try to get that corrosion or rust or whatever it is off this dial so we can restore it. Okay, the little dial has had its bath, and it's already looking a little better. Now, you don't want to go too far here. I'm not trying to shine it up. I'm not trying to lose any patina that might be on the dial. But it has helped already with the smoothness, but you can see there's still some corrosion here. I'm going to try to clean up that with some Neverdol and try to get around and get all this corrosion off so the pinch wheel works better. This is some type of brass coating, and they use the brass coating as part of the dial. As you can see, there's brass on black, and then the other part of the dial, it's black on brass. Say that 5 times. So we'll see how I can do with this, but I'll get this very smooth when I'm done. Okay, it's all cleaned up. The edge is all cleaned up. I was able to get the Neverdol to bridge the gap between the front and the back of the pinch wheel. Got all of that corrosion off. And the coup de grace was this spring that holds the pinch wheel tightly against the dial mechanism. I put a little bit of machine oil on just that spring part, and now it is smooth as silk. This is exactly what we're looking for. Let's get that dial back on. Okay, forgive the noise. I've got my soldering fan running over here. You know, when you're doing soldering, you should always have the exhaust fan running, especially when you're in a situation where you don't have great ventilation and you're going to be doing quite a bit of soldering. So I am using something called double cotton covered pushback wire. Pushback wire. It's wire that basically you can't easily strip it because it's cotton. I suppose you could, but in order to make the connection, you simply push back. And there it is, the already tinned, this is number 22 wire. Isn't that cool? And there's 2 layers of cotton in there, so it's pretty good insulation. This is what was used in a lot of these early radios. And you'll find this kind of wire in, guitar stores, like Sweetwater and so on. A lot of vintage audio gear uses this type of wire, so you can find it around in different colors. So just a quick continuity test. I put the tubes in one by one and noted that we've got 4 ohms showing with the tubes cold, and the switch off, it's open. So that's the filament circuit on the 2 tubes. The rheostat, of course, is on the other panel, and that'll be wired up once I get the other panel on there. But the wires are already to length to connect directly to the rheostat. Also, while I have the tubes temporarily installed on the charcuterie board, I can show you the features of these very interesting tube sockets. As you can see, the tubes are free to vibrate around in the sockets, and this was one way of reducing microphonics. Very, very clever early radio technology. Okay, I've got the fine business carrier net going in the background, but I just discovered something in wanting to put in the grid leak resistor. In looking inside, there's definitely some breakage in the carbon. So this resistor could be part of the problem with this receiver. There's damage inside there. It's hard to see, but the carbon's all broken up. So that's got to be replaced, that's for sure. So I'll have to go into Mr. Whoopi's closet and see if I've got an appropriate grid leak resistor to replace that guy. Okay, here's one I found in the junk box. Oh yeah, 7 meg, yeah, we can deal with that. That'll work fine for a grid leak resistor. So I've done particular work around the grid of the detector tube. As you can see, I have the 100 picofarad grid leak capacitor here, and this is the attachment to the grid right here. This is the grid leak resistor, and that's going over here to the filament minus, which is ground. To ensure that I have an excellent ground, I've added a ground lug right on the front plate. Okay, so right to this plate, I have a lug right here that goes right to that pin. So the resistor and the filament of the detector tube are well grounded right off the bat. So we're starting out with the most critical part of the circuit, the grid input of the detector tube. So just above the regeneration control, which is a potentiometer in this case for the control of feedback, there's a 0.05 capacitor that basically smooths that out, bypasses it, before it goes up into the transformer and then into the tickler coil. That capacitor is leaky, and I can't use it. It was a very poor null on the bridge, and it was very leaky. I did find a oil-filled capacitor. This is a 600 volt 0.1 microfarad, and it measures excellent. So I'm going to find a way to fit that in the box, and that's going to be the filtering capacitor for the Regen pump. So as far as putting that metal case capacitor in the set, I just wanted to verify that those types of capacitors were available in the 30s, and they were. As a matter of fact, by 1929, the Mershon Company, right here, the Mershon Company, had successfully developed and convinced several manufacturers to use their brand new tantalum electrolytic capacitors. Tantalum would be the state-of-the-art in the late 20s for capacitors. Now immediately tantalum caused some difficulty. By the mid-30s, people were starting to complain that the tantalum capacitors were causing some issues. And it's funny that we're still talking about tantalum capacitors today in the 21st century. So I think this is a pretty good stopping point for this video. I'm about halfway into the wiring on the set, and next time we'll complete the wiring and see if we can get some noise out of the Steampunk Regen.